Hello guys, welcome back to another video. Today we're going to be going over and starting our Unit 2, the derivative. This is essential for your calculus history, and it's going to be so fun to do as we get into Unit 3 and Unit 4, and it's just going to keep building upon itself. So, let's get to it. Today we're just going to start about talking, not even about derivatives necessarily. We're going to be talking about the tangent lines and how this relates to our previous knowledge of rates of change. So, let's briefly go over our rates of change from pre-calc. So the rate of change from 2 points y1, if we have a point x1, comma y1, and then we have our point x2, comma y2, these are going to be our 2 coordinate points. Now what are we going to do with these? We're going to set up a little fraction. So we're going to have our y2 minus y1 over x2 minus x1, and this is going to give us our slope from these 2 points. So if we have a point here, it's going to calculate our slope between those 2 points. So how does this apply to tangent lines, and what is a tangent line exactly? So a tangent line is the instantaneous slope of any function at the given point you choose, and you can plug in any point. So it's essentially that's a derivative is the function where you can plug in any point and get the tangent line. However, we're not going to get into that today. That's for next lesson. Today we're going to get into tangent lines. So a tangent line, if we have a graph f of x, right, on the xy plane, and it looks like, here, let's just start out with an easy one, a parabola, upside down. And I want to find the tangent line. The tangent line is the instantaneous slope at a given point, right? So if I want to find, let's say, the instantaneous slope at x equals 1, right, that's a 1. If this is x equals 1, and let's say this is y equals 1, this is my x and y lines, okay? Now I want to find the tangent line at this little point. What's it going to be? Now this is a bad parabola. Let me redo this. Let's do a nice even parabola like that. Now it's still going to be a point 1, 1, right? And if I want to find the instantaneous slope at that point, I'm going to put a tangent line right on it. Okay? We're basically essentially putting a linear function on top of our quadratic. So what's the slope at this very tip vertex of this quadratic? It's 0. So the slope of the tangent line is 0. So m tan equals 0. Now what's the equation for this line? That's essentially our derivative, which we'll get into next lesson on how to actually take the derivative of a function using the derivative function. But for now, let's just make an equation using the graph, which is going to be, we have our coordinates 1, 1, so we can use point slope form. Y minus 1 equals, our slope is 0, x minus 1, so it's literally just going to be y equals 1 as our graph, which is exactly what we have here. But let's do something a little more realistic. I gave you a tricky one to start out with. It should not be a slope of 0 just to begin. Let's start out with, let's do another example of something a little more easy. Let's say I have, here, let's just do this. That's really bad. If I have this kind of function, polynomial, and I want to find the slope of the tangent line right here. Here, let's go right here. I'm going to draw a line instantaneous slope at this little point we're trying to find. And that's, let's use our rate of change to figure this one out. Let's say this point here is 2. This is a 2. Okay. And this down here is also 2. And then this is a 3. Okay. 0. Let's set up our rate of change. So our rate of change is going to be y2 minus y1 over x2 minus x1, which is going to translate to in our function as our, here let's get 2 points first. It's going to be 0 comma 3 comma 0 is our second pair of coordinates, and then this is negative 2, 2 comma negative 2 is our first pair of coordinates, right? So let's plug these in. Our second y value is 0. It's going to be minus negative 2 all over second x value is 3 minus 2, which becomes 2 over 1, which is 2. So our instantaneous slope, which is technically the derivative, which I'll explain later, is 2. So write this function, f of x, this whole blue function, right at this little point, the slope is 2. Now what if we went here? It's different. What if we went here? Different. What if we went here? Different. What if we went here, 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 here? You see there's an infinite number of tangent slopes that make up this graph, and we can take the derivative of this function to find those tangent lines, but I won't confuse you with that now. So if you're excited about this, stay tuned for our next lesson, which I'll tell you how to actually take this function f of x and pull the derivative out, plug in any point you want, and get the instantaneous slope without having to do all this craziness here. It's going to be amazing. So stay tuned, guys. If you liked the video, if you found it helpful, make sure to like, subscribe. See you next time. Bye.